All right, let's start. So welcome to our first webinar of 2025. We're gonna be talking about Gen AI and Web3, which is probably one of the core narrative of this cycle in Web3, but differently from a lot of the stuff that you hear out there. This presentation is gonna be pretty hardcore. AI, fundamentally, I want to focus on some of the trends that sort of emerge in AI in 2024, or not emerge, but more like grew in AI in 2024, and how could they be relevant to Web3? So probably you're not going to hear us talking a lot about agents and decentralized compute and some of the more mainstream things, but so we're going to go a little bit deeper into a lot of AI trends. The agenda is very simple. So I'm going to give you a quick update about ITV, as we always do. Then we're going to talk about changes in techniques and research areas and market areas in Gen AI in 2024, and how each one of those are relevant to Web3. One thing to keep in mind: this is pretty heavy on the AI side, so feel free to interrupt to ask questions. Our team is monitoring the Q&A, so we can take questions anytime. And as we always do, we wrap this up in 30 minutes. So a quick update about ITV, given that this is the first webinar of 2025, we do this every 3 weeks. So I wanted to give you a very basic update of the year. Our institutional DeFi platform grew incredibly fast. We have over 3 billion in asset deployed, over 150 DeFi strategies in production, over 500 risk models. It's a very large scale operation these days, and it's expanding very rapidly. Very soon you're gonna hear a lot of new ecosystem partnerships that we're using for to boost liquidity and capital formation into new L1s and L2s. So if you're working on a new ecosystem, if you're an asset manager or a large allocator in DeFi, please reach out. That we should definitely talk. And then our risk monitoring product onboarded over 40 protocols last year. We have such a cool release coming up that I cannot tell you about it, but probably in the next webinar. And that is gonna surprise you. And we started the year pretty hot. We released risk models for Euler V2 that you can that you can see a lot in that link, and also for POM BTC. And again, we have a fairly cool release coming up. And then in terms of what can you expect next, as I said, you're gonna see us go into a lot of the new ecosystems for liquidity formation, new DeFi strategies for institutions. On the risk radar, we're launching the risk signals for Camino, Giro, Fluid, that's a misspell there, Term, and others. And again, there is a release of risk radar that is very cool. It's a different feature set to what is there right now, but it is gonna I think it's gonna make a difference for anybody who cares about economic risk in DeFi. So what are you gonna hear? The way I want to structure this presentation is, let's talk 2 seconds about the trends that you typically hear in Web3-AI and what they're losing a little bit of relevance. And I want to focus the rest of the presentation on 5 core ideas that sort of expanded in 2024, and the way we think they're relevant to Web3. And then at the very end, there's, I put another 6-7 ideas that I also think they're relevant. So typically, when we think about Web3 AI, there's some narrative that dominates, right? Decentralized compute was very prominent early 2024. So this idea that we could pre-train and fine-tune models using decentralized networks of GPUs, I think this trend continues to under-deliver, and it's going to be like that because if you're pre-training models today, the architectures at work require very concentrated clusters of GPUs in very close proximity to each other, and that hasn't really changed. There has been some research from news research with models like Distra and all that have proven that decentralized training could be done, but really the companies that are training models, particular baseline models, they can do it with highly concentrated clusters. And also, as we're going to talk about, the market is moving from this pre-training to things called mid-training, post-training, and that even so that definitely for pre-training is probably going to concentrate on the large AI labs, and then obviously there are agents everywhere. And a lot of those with in the meme coin movement with agents in Web3 has gotten a lot of momentum. Reality is that most of those agents have really no practical adoption today. And the way the agentic market is evolving in traditional AI is that the winners, the ones that are gaining adoption, are very highly specialized domain-specific agents. I use example of Devin. This is an AI engineering agent created by a lab called Cognition Labs that can work on engineering tasks. So it's equivalent of your junior engineer in a software development team. It can fix your bugs in GitHub and all that. It specializes on those type of tasks, and that's in some momentum. But you need, so the more simplistic agents are, there is still some work to be done. Definitely there is a play for Web3 on agentic, but it's by far overhyped. And then another trend that gained a lot of narrative at the beginning of last year was this idea of combining zero knowledge proof and generative AI. In my opinion, and I tend to be very bold about this, this is a solution looking for a problem. So it does work, but nobody's asking for it. So in terms of adoption, it's probably not where I will focus time. However, 2024 was a fascinating year on Gen AI, and the ones of you who know me know that I spent a lot of time on Gen AI research, and I have incubated other ventures in that space. So there are many things that change, and a few of them were quite surprisingly, and they could have some meaningful implications in Web3. Given that we try to keep these webinars to half an hour, I'm going to focus on 5 trends, and then we can talk about some more generic things. So there's been a complete shift from traditional pre-training of frontier models to this thing called post-training. There is a middle there called mid-training that people don't talk too much about, particularly with the emergence on reasoning models. We're going to talk about that. Then there is the small models, this term that Microsoft coined called small language models, SLMs. They have gotten a lot of attraction, but the most interesting thing is that in the last quarter of 2024, there were a series of models that came out that proven that small models could actually do reasoning. And this is something that I was on the fence of until 6 months ago, that there are many people, me included, that thought that reasoning requires certain scale. It's a byproduct of scaling laws, and I was wrong about that. So it turns out that actually these smaller models can exhibit reasoning capabilities, which is a game changer. I want to talk about this idea of open-ended AI. These are AIs that can work on long horizon tasks. Think about a couple of months, right, or several days. And there is a body of research in that area. I'm going to show you a couple of those that is fascinating. One thing that came up in 2004 and 24 that is quite relevant to Web3 is that there's several technology releases that prove that synthetic data generation really works. From pre-training entire models with synthetic data to do a lot of post-training exercises with that, and that is super interesting. And I think one of the trends that became very strong in 24 was the need for better evals. This has been an overlooked problem in Gen AI for a couple of years, and it gained a ton of relevance. So let's look at those in detail. So let's start with the shift from pre-training to post-training. So if you look at Gen AI, in the last few years, the traditional workflow is you take so you take a transformer architecture, you pre-train it into a lot of unlabeled data from the internet, very raw data, spend 6 months pre-training that, and the output is a file. Literally, we spend 6 months of compute to get a file that contains the weight of the model, and then you go into this process called fine-tuning, and fine-tuning in general is for two things. For baseline models, I mean, one is for instruction following, like the model do what you're telling it to do. And the other is for chat, because it's just a way that so most of when you look at GPT, 4 or some of the Llama models, you have the baseline model and you have the instruction tune and the chat tune. And then obviously you can fine tune for very specific use case. Now with GPT-01, there was a shift. So GPT-01 is this model that allows you give it a task and it works on it for a couple of minutes or 45 seconds or longer inference cycles. So there was a shift of the compute usage from pre-training, right, where you use a ton of GPU, to inference. And to achieve that, so that allows the model to work on more complex reasoning tasks, that is decomposing a model into a smaller task. To achieve that, there was this area of instruction tuning that is typically referred to as post-training, like you train a model and then you go into this other process, gain a ton of relevance. So what is happening now is that you're seeing a lot of the AI labs spend a lot of more compute resources and time on that post-training phase than on the pre-training phase. Pre-training obviously is still a cornerstone of building models. And this is what many people call the race for reasoning, the reasoning race, that you see a lot of these labs pushing to achieve new milestones. So to give you an idea, OpenAI released O1, and they hinted, right, the capabilities of O3 they did these 12 demos at the end of the year. Google added reasoning capabilities to Gemini Flash. And then there has been a number of reasoning models. The UC Berkeley lab, Sky, releases in T1. We're going to talk about it in the next section. The DeepSeek lab just released a model called R1 that is extremely strong on reasoning. And the thing about these models is that they use a lot of compute at the inference time. So that's how it shifts, right? From only pre-training, if you use GPT-4, obviously a pre-training compute is months. The inference compute in a cycle is very low. Obviously, it accrues across many users. But in the reasoning models, you tend to use a lot of compute. And in order to achieve that, you need to work, meaning you can work on more complicated tasks, and that requires a lot of post-training cycles. So now the thing is that now reasoning, it goes from a cute thing to everybody wants reasoning as part of their LLM, so it becomes a core feature. Why is this important to Web3? So a few things. So if I give you a problem, you decompose it into multiple steps and arrive into input. The dominant technique in this space in AI is called chain of thought, like COT. That is that decomposition. There are many variations of this, skeleton of thought, graph of thoughts, things like that, but fundamentally they all do the same. They take a problem, partition into smaller tasks, work on those tasks, and sequence a problem. Nobody knows what GPT-01 really does, but the winning theory is that it does search. It does a Monte Carlo search over a large potential, a search space of hypotheses, and start concatenating a lot of those to arrive to a solution. So keeping traces of those things is important, because you don't know how the model arrived to an output. And if it's answering a question, that's easy. But if it's a complex problem, you really want to have those reasoning traces. So blockchains are very good at this. Now, the interesting thing is, while decentralized GPUs are not good for pre-training and fine-tuning, for this decentralized inference, they kind of make sense, because you can decompose a model and distribute the load across many different, let's call it agents that work on that part and aggregate to that. And And the idea of traceability and all this, it plays a very strong factor. So as these models, particularly the open source one, become more prominent, the Web3 angle here is very relevant. Somebody asked, is reasoning model causal inference? Not only, right? So a lot of models do obviously causation analysis, but there are different ways of reasoning. Like if you're familiar with cognitive theory, system 1, system 2, what we call reasoning is more on the system 2 side. That is, you need to work on the problem for longer, and that could be decomposed in many ways. There is a branch of reasoning that is mostly memorization, right? Like when we learn multiplication tables and things like that. And there are entire branches of reasoning that go into generating code and things like that. So there are many forms that go beyond causal inference. So another trend that became super relevant in 24 is a small model. So small models have been around for a couple of years. The main argument for these things is you don't need all the compute, the paying per token, and all that of GPT for a specific domain scenario. You're paying for a lot of compute, you're paying for a lot of hallucinations and things like that. But they always, most people consider a smaller model lower quality than the big models, but that is changing quite a bit. So now we have small models, a small look at 1 to 7 billion parameter range that have matched the performance of the top models in the market on different areas: math, coding, reasoning benchmarks, and things like that. So the cute thing about this is that you can run these models in commodity hardware, right? You can run it on your phone, you can run it in CPUs. In many cases, they don't even need GPUs for inference. So it adds IoT devices, it opens the door to a lot of things. So to give you some of the highlights of 4, Microsoft, that is actually the company who coined this term, SLM, they coined that term with the first release of a model called Phi that was trained on textbooks of mathematics and computer science. Now they're in the 4th release, and the 4th release that is not that small anymore. It is showing an incredible reasoning capabilities when it comes to those areas. A few days ago, there is a very famous lab in UC Berkeley that used to be called RISE. It used to be called AmLab, then RISE, now Sky, that they just released a model called T1 that they claim that they trained it with $450 and is up there in reasoning benchmarks. Google added, it has a branch of models called Gemma that is not so strong on reasoning, but it's pretty high quality as well. Now, why is this relevant to Web3? Well, it's a smaller model, so they could be run on decentralized networks. They're low-cost inference. I've been fascinated with this idea of a crypto GPT. Like many industries are creating GPT's version of the foundation models for that industry. Crypto is a data-rich industry, so you can potentially pre-train a model in the entire corpus of knowledge of the crypto industry, all blockchain transactions, all articles, all white papers, and things like that, and create that that very unique IP. And again, reasoning tracing, as the same as a previous trend becomes very important. Another angle, this is one that I'm fascinated by, is the emergence of this area called open-endedness AI. So if you think about reasoning models as things that could work on a few seconds to a few minutes problem, think about the open-endedness models as something that can work for weeks on a given problem, which is actually what we do, right? Like if you're writing a PhD thesis, you cannot do that in a few minutes, right? So until now, all the foundation models have focused on that short time. And this area of research has been around for a while, but with very poor results. So in 2024, there was a lab called out of Japan called Sakana that they're working on alternative architectures to transformers. That they published this work called the AI Scientist, and the AI Scientist is a model that works on machine learning papers. And they have the model produce a series of papers with new theories in machine learning, and they had a peer review for machine learning researchers. And I know for a fact that there was a group at Columbia that was working on exactly one of those problems. And the model was able to crack this in a few days, publish a paper, get a peer review. If you Google the AI Scientist, go to the website, you can see the papers. These are 20-page papers with a lot of math. I actually run some tests to have it generate papers for new DeFi protocols. And it comes up with a stuff pretty complicated. That I need to read like 20 times to get a handle on it. So these are models that can work on very long-term horizon tasks. Google Gemini just have this thing called Gemini Research that is part of the Gemini Advanced Edition that it does the same. It could work on, I mean, a few hours on a task. This is, hey, I need to optimize my inventory, go away and solve this task for me, come back in a week type of problem. NVIDIA has this thing called Voyager that it actually allows to explore Minecraft worlds and create new worlds completely autonomously. And it's that type of long-term horizon execution. So why is this important? Well, same argument as a reasoning task, except that at a much larger scale. Right here, we're talking about decomposing a problem into many, many tasks. Go execute those tasks, review results, re-execute and aggregate in different ways. So you can see that decomposition taking place on decentralized networks, and traceability of trust is essential, right? Because if you have been working on something for a week and you come back and they're like, and you want to retrace back a lot of those steps, you need to make sure that you have like proper traceability of all that, and blockchains excel at that stuff. So the fourth trend I wanted to talk about is this idea that synthetic data generation really, really works. So in the press, you can see some sort of dystopian headlines of things like we're gonna hit a data wall and we're running out of data and all that. I don't. So what happens after we don't have more data? I think that's questionable. Consider that we generate a tremendous amount of data every single minute. But the problem is not really that, right? The problem is that the current generation of frontier models have been trained on very raw data. The entire internet is about outputs. So you see a paper, right? We don't have any data of how the author created the paper, right? You don't see the creation process. You see the output. So the entire internet is based on outputs. The more, if we want to shift things like reasoning and all that, you need to go to the reasoning traces of that output, and that doesn't exist. So so that is really where the problem is. To unlock the next level of performance, we need to move from those output data sets to the reasoning traces of those data sets. And it turns out that this particular, the very high caliber models are very good at generating those things. So there are many people that has opposed to this for years, but 2024, it actually proved that it worked. First of all, if you're building for every frontier model that you use, it uses synthetic data, because when you're gonna do the instruction tuning phase, everybody generates synthetic data sets for that. So if you never pre-train a model, probably you don't have to deal with that. But if you have, when it comes down to instruction tune, you need to use synthetic data. So this is just using at a scale. And because now, as I said in the first point, we move from this pre-training to post-training phase, synthetic data on that post-training area is much more relevant. So proof of that is that synthetic data platforms that were not relevant a couple of years ago in 2024 raised massive amounts of money. There are a couple that I like, Gretel AI, Mostly AI. They raised substantial rounds. The Allen AI Institute, this is a AI frontier lab funded by the Paul Allen Estate. They have launched a bunch of tech and models. They released this thing called Tulu 3, that is essentially a post-training framework in which synthetic data generation is super important. 5.4, there is an important part of the training corpus of 5.4 that Microsoft has publicly said that is based on synthetic data set. And just a few days ago, this lab, a Chinese lab that was incubated by a quantitative trading firm called DeepSeek, we're going to talk about those guys at the end. They released a reasoning model called R1 that is matching GPT-01 performance at a fraction of the cost. And R1, it uses a post-training technique called reward optimization. That entire thing, the whole thing, has been with synthetic data. So this is proving that synthetic data is going to be a relevant trend. And decentralized networks are great at doing this because synthetic data is a lot of running computation jobs and refining. So you can see a distributed network that you offload a number of synthetic data generation jobs. You have consensus mechanisms to check whether this is valid, not high quality, not. And then one problem that we have in AI is the data provenance, right? Everybody complains about it. Well, with synthetic data, with blockchains, you can actually trace all that. So if we assume that synthetic data is going to be more and more important, on that, blockchains can really play a role. And then the last of my 5 points that I want to talk is the importance of evaluations. So evaluations have long been an ignored problem in AI. Obviously, everybody knows about benchmarks, but there is a number of problems with today's benchmark. One of them is they get memorized, right? Because they're public, so the foundation models, they memorize those things as part of the training process, quite often by accident, but it doesn't matter, right? It makes a benchmark irrelevant. There is a lack of evaluation, so everybody agrees that we need a lot of more evals. Then there is, because these LLMs are complete black boxes, nobody understands how they work. There was an entire body of work in previous ML called interpretability that essentially could tell us how a model works. In frontier models, there is an area of research called mechanistic interpretability, but it's very, very early. So we just don't know how to understand an output of a model. So benchmarks is the thing that we use for that, to see this model is good at math and good at coding, not so good at, Chinese financial markets. And there is a disconnection between those evals, the scientific evals, and how we use models. So if you're using a model for an agentic workflow that interacts with your CRM, there is only so much that you care how good the model is at math, and certainly like in frontier math, right? So that this is becoming a major issue in the industry. In 2024, we saw a number of things. So the big AI labs, the OpenAI and Anthropic and Google, they're focusing on a handful of benchmarks, and those guys are focusing on benchmarks that are harder and harder to solve. We saw a number of things like this one that came out called Frontier Math, that they claim to be the hardest math benchmark ever created. There is a famous one called ARC, that is one that sort of is supposed to be like a test for AGI. It has been around for a while. They're working on the second version. Now, there's a very famous AI computer scientist, Francois Cholet, that he's a creator of a very famous framework called Keras, who literally left Google after over a decade to work on evals. He actually just started a company to work on new architectures. But this is a problem. Now, if the big AIs are focusing on 5 evals, the open source models are sort of testing on last year's evals. So you see the open source models caring a lot about the evals that OpenAI probably doesn't care too much about. So there is a little bit of a disconnect there. Now, what is a Web3 angle here? So there is a massive, so we think trust transparency matters a lot when it comes to evaluation and benchmarking. You can use crypto incentive to create new evals. You can use distributed networks to run evals. And this is one area that fits very nicely with Web3. So to wrap it up, there is other trends that are quite relevant. There is one that I was trying to look for a cool name, and I call it GPU rich versus GPU poor. So this whole GPU thing has gotten quite better, right? Like GPUs are accessible today. You don't have the whole race to between before that nobody could, the scarcity before that you couldn't access GPUs. But the interesting thing is you have the GPU rich companies, the OpenAI, Anthropic, that raised billions of dollars and gave it all to NVIDIA type of thing. And you have the GPU poor startups that don't have any GPUs. So the latter can use cloud environments like Amazon, Microsoft. Today, that actually works. Last year, there were a number of companies that were somewhere in the middle, right? They raised maybe 100 million or something to buy a lot of GPUs and build front-end models. And we saw the majority of those completely collapse. So Character AI famously is one of the authors of the Transformer paper. The founder went back to Google. Adept was another of the authors of the Transformer paper, was working on agents, computer vision agents, and they went back to, they're working at Amazon right now. Inflection, that was started by Reid Hoffman and Mustafa Soliman. Mustafa is one of the three co-founders of DeepMind. Mustafa is now the head of AI, Apply AI at Microsoft, and they had to basically, the company is just doing something else. So there is no middle class of this. Either you're close to research and you're going to work on those problems for many years, or you're close to the customer, right? But if you're somewhere in the middle, that's a really bad market to be. There is more developments on agents. This market is still very, very early, but you're seeing a lot of innovation in agents. There is some interesting ideas of running LLMs in your local computers and with your personal data and things like that, completely not having your data flow to a cloud environment, and we're seeing some interesting things there. In 2023, we saw this movement around this trend called state space models, that it was an alternative to transformers. And there were companies funded to do this because we need a new architecture. It turns out that most of those disappointed. So transformers is still the architecture to go. Today, there is one exception to this. Is a company called Cartesia that is been doing a lot of SSMs for audio, and those seem to be doing well, but everything else has been quite disappointing. And speaking of new architecture, there's some new ideas. I mentioned Francois Cholet. His new company is working on this thing called program synthesis. That is this thing that I can generate mini programs to advanced reasoning and things like that. And there's some interesting ideas that might be alternative to transformers. Coding is becoming a tier one problem. Like, if many people think that solving coding is a path to AGI, like you can decompose any problem in the world mostly as programming steps. So if you can build a massive software application from the ground up, probably that's a massive iteration to AGI. And the most are very, very good at coding. Like the little coding I do these days, I use a lot of AI for my pilot and things, and I think there is no reason not to do it because they make you so much productive. And I left this one for the end. So I mentioned this Chinese lab that was DeepSeek, that was incubated by a quant trading firm. And they so the Chinese models in general are surprising, right? Like they Alibaba with the Quine models, O1 with the Y models. There's several that are extremely good. But this DeepSeek team, they keep just releasing models after models after models. and they match with the performance of the top models. The last iteration was this thing. They did one in December called DeepSeek V3, amazing, followed by a thing called R1, that is a reasoning model that actually I'm going through a lot of testing on that, but it does match the performance of GPT-o1 at a fraction of the cost. The thing about DeepSeek is that has been involved in a lot of controversy around stealing secrets from OpenAI, using the outputs for OpenAI from particularly OpenAI. So there are some jokes in the industry about this. You know how many stolen secrets there have been from OpenAI based on the DeepSeek performance type of thing. So it's certainly very controversial, but they're very good. So and we think a lot of these models are gonna they're really pushing the boundaries of open source. A lot of these Chinese models really dominate the open source leaderboards today. And that's it. So next in 3 weeks, so I would like to go to Q&A. I have a couple of questions. In 3 weeks, so we talk about real AI today. We're going to talk about fake AI in the next one. So we're going to talk, no, I'm just joking, about AI agents and DeFi. So what you're seeing with AI 16C, virtual, the hype, and all the stuff. So our head of research, Lucas Sotomoro, we have a ton of research about this, so it's gonna be interesting. There is a question about what are the legitimate use cases at the intersection of Web3. By the way, you have the registration link on the chat, so go register. The real use cases at the intersection of Web3 and AI. I think in general, most of the stuff at the intersection of Web3 and AI, most Web3 AI companies are still in the low side of the adoption curve. So the entire AI market is Web2. So you need to be able to sell to those companies. With Web3 technology, that's not easy. There are some impressive companies in the space, Sahara, on the agentic space, Hyperbolic. I think that those guys are great, but it's still very early. But obviously, this idea of using decentralized backends for AI workflows it has a ton of potential. Any other questions? Could you provide a real example of decomposition, like how to decompose a real task? So any of these reasoning tasks I use it today, behind the scenes, what they do on the chain of thoughts is concatenating a number of thoughts to arrive to a final answer. So if you take a problem of I need to optimize my inventory that goes to a number of things. I need to look at my inventory. I need to do a number of web searches. I need to go with the results. I need to formulate different hypotheses, maybe experiments. So that is what that decomposition happens. So when you go to open a GPT-o1 and you tell it, hey, give me some ideas for, I don't know, a screenplay about something, and it gives you, it goes and comes back 45 seconds with a very comprehensive plan. That is what it's doing behind the scenes. It's decomposing that into a number of steps. Now, the thing is that many of those steps could be run in parallel, and that's what the decentralization part makes sense. The second thing is that OpenAI doesn't tell you what those steps are. The reasoning traces, and I think providing transparency about that is super important. Any other? I think that's it. So if there are no more questions, I wanted to thank you very much for joining, and we'll see you in 3 weeks. Thank you very much.